Okay, so we are now in the muscles, and this is the last topic for your period 1. Now, there are actually 3 types of muscles found in an animal's body, and we group the muscles according to their striation and according to their innervation. So when you say skeletal muscles, these are the muscles that are attached to the bones. So striation is they're striated and their innervation is voluntary. So meaning there's the movement of these skeletal muscles are consciously being moved by the animal. So let's say when the animal wants to abduct its leg, because let's say the male dog wants to pee or he wants to urinate, so he abducts his leg. So he does it with his conscientiously, or with he's thinking that he's going to abduct his leg. So it's a voluntary movement. And when you say cardiac muscles, these are the muscles that are found in the heart. These are striated. When you say striated, these are muscles that these types of muscles that are classified as striated, they're always working. They're flexing, they're extending, and as for the heart, it's always pumping. However, its innervation is involuntary because you cannot control it. You don't consciously control your heartbeat, right? And then we have the visceral muscles, and they are classified. The visceral muscles are the muscles later on in your histology, you will find out that there are several layers of your organs, and there's a layer called tunica muscularis, and that's where you can find these visceral muscles. They're classified as smooth muscles, and their innervation is involuntary. So this is how they look like, their muscle tissues. So if you notice the striated ones, like the skeletal muscles over here, so there's striations. And this is the cardiac muscles. And you see the smooth muscle. So that's how they look like. Now we go to origin versus insertion. Later on in your comparative anatomy, you will, in your lab, you will get to know the insertion. For the lab, for this one, you will identify these muscles. But for the lab for comparative anatomy, you will find out where are their origin and their insertions, and what nerves do innervate them, and what are their corresponding actions. So when you say origin, this is the proximal attachment. So for extrinsic muscles, these are the least movable attachment, and you will later find out what are extrinsic muscles and why they are grouped as such. Then we have insertion. The more distal attachment. For extrinsic muscles, these attachments are the movable ones. So with terms of muscle attachment, we have fleshy attachments, tendinous attachment, and aponeurotic attachment. When you say fleshy attachments, the apparent direct attachment of muscles to the bone, and they're attached to the periosteum of the bone by very short tendons. And when you say tendinous attachment, the dense connective tissue connecting the spindle shape or pinnate muscle of the bone. Example of this is the quadriceps femoris muscle of the thigh. We also have the gastrocnemius or the calf muscle. We also have the aponeurotic attachment, also known as aponeurosis. And these are flat tendinous sheets associated with flat muscles, and this is seen in the muscles of the abdominal wall, so as seen here. So these are the different abdominal muscles. So they are forming an aponeurosis type of attachment. Muscle contraction. This is the shortening of muscles caused by change in the alignments of bones around a joint. So movements such as extension, flexion, rotation, abduction, adduction, and circumduction can cause muscle contraction. Muscle's action would depend on its location. and muscles work together to form motion-produced, smooth, and controlled. This is according to Pasquini and Spurgeon, 1988. So muscle functions, they're classified as prime mover or agonists, and you have the antagonists. So for the prime mover or agonist, these produce characteristic movement at a joint. Examples of this is the biceps brachii, which is the prime movement for flexion of the muscle joint. So if you try to flex your elbows towards your shoulder, that's your bicep muscles doing that. So try doing the flex. So you flex your elbows, your head should be going towards your shoulder, and that's your biceps muscles. Now, if you go to the antagonist, it's the opposite movement of the agonist. So it aids the prime movers by slowly relaxing so the movement is smooth and controlled. Examples of this is the triceps brachii, which is the extensor of the elbow joint. So try to extend your elbow joint. So the movement is being controlled by the triceps brachii, which is on the posterior part of your arm. Then we have the synergists. So derived from the Greek word syn, which means together, and ergon, which means work. These are muscles that indirectly helps the action of the prime mover. And then we have the fixators. These are mostly found in the limbs, and the proximal end will stabilize the muscle while the distal end will moves the muscle. Muscle actions would include, as I've mentioned, extension, flexion, adduction, abduction, rotation, and circumduction. So here's your muscular arrangements. So the tendon is the one that connects the bone with the muscle, and the entire muscle is being covered by a connective tissue called the fascia. So for those who have dissected a frog, or for those who were able to do the dissection before, those things that it's very hard to remove and we just remove it using our forceps, those are the fascia, and it's very thick connective tissue, and it's quite tough. And then this is muscle. That's the one chunk of muscle, and each muscle has what we call the epimysium, perimysium, and fasciculus. So these are, and you'll get to know these even further when you go to histology. And then per endomysium is we call the endomysium, and you have a muscle fiber over here, muscle cells, or we call it the myocyte, spelled as myocyte, myocyte. Muscle arrangement, we also have the parallel muscles. So the muscles, this muscle bundle run parallel to each other on the entire length of the muscle. It allows greatest shortening of the muscle but with less contraction strength. Examples of this is the sartorius muscle of the hind leg and the abdominal muscles. Then we go to the pennate muscles. These are parallel muscle bundles converge on a tendon at an angle. Such arrangement will allow more bundles, thus stronger the contraction. However, there will be less shortening due to the shorter length of the muscle bundles. So we have different types of pennate muscles. You have the unipennate, bipennate, and the multipennate muscle. Muscle tone. This is a slight state of tension in most of the skeletal muscles. Even at rest, the animal's muscles that maintain posture are still not in the relaxed state. This is achieved by a proportion of the motor units within the muscle being activated so that some muscle fibers are contracting while the others are relaxed. So while even you're standing or you're sitting, there are certain muscles that are actually working to keep your back straight, to keep you standing. two types of muscle contractions. So these are, we have isometric contraction and isotonic contractions. When you say isometric, this happens when tension is generated in the muscle and the muscle tone will increase, but the muscle does not shorten. So examples of this is when you are just standing, but still the muscles on your legs are not might be contracted, but it doesn't shorten. When you do isotonic contractions, however, the muscle actually moves and it shortens. So example of this is when you try to flex again your biceps brachii muscles, it shortens. And when you extend it, it shortens and it contracts. But when you extended it, it relaxes and it becomes longer. Intrinsic versus extrinsic muscles. So intrinsic muscles, these are muscles within one region of the body where they have their origin and insertion, and they act on the bones on that part only. Extrinsic muscles, these are muscles that run from one region of the body to another to alter the position of the whole part. Examples of these are some of the muscles of the thoracic limb, which are originated, in which their origin is on the trunk or the main body itself. Examples of these are the trapezius muscles, the brachiocephalicus, the cleidocephalicus. They also have the rhomboideus. We also have the pectoral muscles. We also have the latissimus dorsi. These are the muscles that are attached to the body of the animal, but their insertion is on any part or bone of the foreleg or the thoracic limb. So later on, when we go to the lab, you will get to know these muscles well. Now we'll start with the different types of muscles or different muscles on the body. First, we have the muscles for mastication. When you say mastication, it's chewing. So for closing the mandible, we have the masseter, temporalis. So the masseter just happens to be the one that is...
The masseter is one of them.
So the masseter just happens to be where you're located on the masseteric fossa on your mandible. That's where it is. While the temporalis muscle happens to be the largest and strongest muscle of the skull, it originates on most of the bones on the cranium. So including the parietal, temporalis, some even parts of it is attached to the occipital bone. And then we also have the pterygoids. There are two, the medial and the lateral pterygoids. Then we have the opening of the mandible, and this is being represented by the digastricus muscle. And for the side-to-side movement of the jaw, we have the pterygoids, or we call them the pterygoideus. So this is how they are arranged. So this is the temporalis muscle. So it's inserted into not just the parietal, occipital, and the temporal, it's also being inserted into the frontal. And then the masseter. So the digastricus is from the angle of the mandible up to the jugular process. So the pterygoideus, they're just behind the digastricus muscle. So this is how they look like. They're using an actual dog, a dead dog. So this is the temporalis, and this is the masseter, and you have the digastricus over here. And then we go to the muscles of the eye, also known as the extraocular muscles, and they're all classified as extrinsic muscles because their origin is on the orbit. And their primary function is movement of the eyeball within its bony socket or within the orbit. So for the muscles of the eye, they have four recti muscles. We have the dorsal, ventral, medial, and lateral. And all four muscles are inserted on the sclera of the eyeball near the X and Y axis. So their movements would include, for the dorsal, it's upward, ventral, downward, lateral, outward, And the medial rectus is for the inward movement of the eyeball. They also have oblique muscles. So they rotate the muscles at its visual axis. And the last one is the retractor bulbi, which forms a muscular cone around the optic nerve at the back of the eye, and it's the one that pulls the eye deeper into the socket. So this is how they look like. So when you say superior rectus, this is the dorsal rectus, and inferior rectus, this means it's the ventral rectus, and then we have the medial rectus and the lateral rectus. And then we have the dorsal oblique, and we have the ventral oblique muscle. And then we have the optic nerve, and then we have the retractor bulbi muscle. The retractor bulbi actually has 4 fascicles. So these are the fascicles of the retractor bulbi. Sorry, going back. Okay, these are 1, 2 fascicle of the retractor bulbi, and then we have 1 and another one over here. It's superimposed by the drawing. And we have 4 for the retractor bulbi. Then we have the muscles of the vertebral column. These muscles lie dorsal to the transverse processes of the vertebral column, and they support the spine, extend the vertebral column, and will allow lateral flexion. We also have the hip axial muscles, and these muscles lie on the ventral side of the transverse foramen, and they flex the neck and tail and contribute to the flexion of the vertebral column. And then we have the muscles for respiration, starting with the external intercostals. Its origin is caudal border of one rib, and it's inserted into the cranial border of one rib, and they're confined only to one intercostal space, and this is the function for muscle inhalation. So we go back to this one. So for the external intercostal muscles, so this is one rib. Okay, this is one. So this is rib 1. So its origin is on the caudal border. So it's here. And then it's inserted into the cranial border of the next rib. So it only occupies one intercostal space. While when you say internal intercostals, this is found below the external intercostals, and its origin is the cranial surface of one rib, and it's inserted caudal surface of the rib behind, and this is the muscle for exhaling. So for our internal intercostals, so let's say it's here, so its origin is on the cranial border, which is over here. So this is rib number 1, so it's inserted here, origin here, and it's inserted into the caudal border of the next one, next rib. So it occupies around 2 intercostal spaces. Now we have the diaphragm. So the main muscle for inhalation, so if you're a singer, if you have been trained by a coach, a voice coach, they always keep you sing with your diaphragm. And it's the main muscle for inhalation. So a sheet of muscle that separates the thoracic cavity from the abdominal cavity. And it consists of a central tendon and a muscular periphery that originates from the lumbar vertebrae, caudal ribs, and sternum. They have right and left crura that are thickened muscle bundles found in the lumbar portion. So you have a central tendon. So this is the central tendon. And these are the crura over here. So they actually have holes on the diaphragm, and we call it hiatus. And I think there are 3. 2 of them are named hiatus, and 1 is a foramen. So we have the aortic hiatus, which transmits the aorta, which is a major blood vessel. Later on, when we're going to discuss our beloved cardiovascular system, you will get to know the aorta. And then we have the azygos. When we say azygos, this is a vein. So a very important vein, which we'll later discuss in detail what's its role in the cardiovascular system. So as this is an azygous vein, okay? And then we have the thoracic duct. So this one is part of the lymphatic system, which is an adjunct chapter right after the cardiovascular system, and you will later find out its importance. Then we have the esophageal hiatus, which transmits the esophagus, which is a tubular organ that connects the mouth with the stomach, and the vagal nerve trunk. So the vagal nerve, or we call it the vagus nerve, is one of the cranial nerves. And later on, you'll find out on the next topic, which is the nervous system, what's its importance and what its role. And the last one is the caval foramen, which transmits the caudal vena cava, which is a main vein that you will later on find out what's its importance. So a lot of very important tubular organs are transmitted via the diaphragm through these three openings. Then we go to the muscles of the abdomen. So we have the external abdominal oblique, which is the most superficial and originates from the lateral surfaces of the ribs and lumbar fascia, and it terminates at the linea alba. So we go back. So this is the linea alba. And later on, when you go for surgery, you have the importance of the linea alba because that's a key landmark when you go and have your incision. So that's where we do our incision when we go for an laparotomy, or we do cesarean section or ovarian hysterectomy to your dogs and cats. That's a very important landmark. We also have the internal abdominal oblique. This is intermediate muscle of the lateral abdominal wall. And again, it terminates at the linea alba. We also have the transverse abdominis, which is the deepest of the lateral abdominal wall. Again, it terminates at the linea alba. And the rectus abdominis, which is a broad band of muscle on each side of the linea alba and forms the floor of the abdomen. It usually originates from the first rib and sternum and inserted into the pubis by means of the prepubic tendon. So linea alba. So this is how it looks like. So this is very important. Then we have the inguinal ring, which is a slit-like opening in the aponeurosis of the abdominal muscle near the groin or pubic region. So this is the one. Serves as passage for blood vessels that supply in the external genitalia and mammary glands. Also transmits structures from the spermatic cord to the scrotum. So a condition wherein the inguinal ring becomes enlarged and allows structures such as part of the intestine or some adipose tissue to pass through this inguinal hernia. And it has to be fixed. Now we go to the muscles of the forelimb, and these are the extrinsic ones. So I have here a colored one. So this is the non-colored one, so you can see how they look like. So we have the trapezius. This is the trapezius muscle. We have the pectorals. We have the latissimus dorsi. This is the latissimus dorsi. And we have the brachycephalicus, which is this one. This is the brachycephalicus. So take note that their origin is on the trunk of the animal. For example, for the latissimus dorsi, this one, letter D, its origin is actually here. And it's inserted into this one on the caudal border of our beloved scapula, and also, here on the back of the triceps brachii muscles. You get to know these even more in your laboratory. Now we go to the muscles, the intrinsic one. We have the infraspinatus or supraspinatus, which is attached to the subscapular fossa of your scapula. We also have the infraspinatus, which is attached to the infraspinous fossa of your scapula. Then we have the triceps brachii. So remember the tuberosity for triceps brachii. Yep, it's very tuberosity, line. And then we also have the biceps brachii, bicipital groove, and then we have the brachialis muscle. Muscles of the thigh, we have the gluteals. So they're divided into 4: superficial, middle, deep, and tensor fasciae latae. Dogs don't have the gluteus maximus. And you will be surprised where is their gluteal muscles. You'll be surprised the placement. And then we have the hamstring group, which is composed of the biceps femoris, semitendinosus, and semimembranosus. And then we have the quadriceps femoris, not scratch the quadratus femoris, because the quadratus femoris is a totally different muscle. So it's just quadriceps femoris, so it's extend the stifle. So the muscles on your front thigh, that's the entire quadriceps femoris. We also have the adductor muscles. So in our language, these are the muscles found on your singit. So these are the pectineus, sartorius, and the gracilis. And then we have the gastrocnemius. So this is the gastrocnemius. Unfortunately, you guys did not dissect a frog for your or you don't have zoology, because usually with zoology, there's always that, I don't know, but in my generation, we look forward to zoology because that's where we will dissect a frog. And we like zoology because it somehow gives us, it hastens, it already conditions our mind that our course, if we do have zoology, is most likely going to have anatomy, and it gives us that preview of what are the things that we need to learn. Now, this is the gastrocnemius. It's very prominent. So this is the calf muscle, and this is its tendon, the common calcanean tendon. And as when I was talking about the bones on the hind legs, your assignment was, what is the other term for the common calcanean tendon? And this is the calcaneus of the fibular tarsal bone. Now, we are often being, while we were talking about bones, joints, and muscles, we often have these tendons. We often met these tendons, ligaments, fascia, and let's know what are they. Tendons are a sheet, cord, or band of strong, white fibrous tissue that connects a muscle to a bone or other structures. So the example of that is a common calcanean tendon. We also have the patellar tendon. So those are examples. And then we also have the ligament, which is a band of fibrous tissue connecting bones or cartilages, serving to support and strengthen joints. A double layer of peritoneum extending from, it can also be a double layer of peritoneum, which is on your abdomen, extending from one visceral organ to another. So the ligament is more like a seat belt. So it keeps the bones into proper position or proper placement. Ligaments can also be found in internal organs, particularly in the abdominal organs, and it keeps these organs in place. So when we discuss breathing, you have the ligaments on the uterus. So those are examples of ligaments on the visceral organs. And then we have the fascia, which is a sheet or band of fibrous tissue that lies deep to the skin or insert muscles in various body organs. Always remember that, dog. On my most prominent running injury right now is, because I'm also running, is I have plantar fasciitis. So the fascia of my right foot, particularly in the heel area, is very painful. That's the reason why I need a cushioned shoes. So no matter how a lot of people would convince me to go for a flat racer, no, I should have a cushioned shoes all the time when I go for a run. And I think that's it. So that's the last topic for our period 1, and I wish you good luck for your long quiz, and get ready for period 2 because period 2 is quite lengthy with a lot of information that's loaded. So until then, see you later, guys.